Here we have a proof question, but the trick is that we need to consider two cases. We're told that n is an integer, it's not divisible by 3. So case 1 is that n is going to equal 3k. That would be divisible by 3, so we have to add 1, and that will leave a remainder. And then case 2 is going to be that n is equal to 3k plus 2. Now you don't need to consider any other cases because 3k plus 3 would be a multiple of 3. So these are the only two we need. Just to add, we could write 3k minus 1 for the second one, but and if you remember to do that or you want to do that, that's fine. I'm going to stick with 3k plus 2 here. So we just should add that k is an integer. That's important. Okay, and maybe I should even write that n can be split into two cases. Okay, let's do this. So we want to prove that n squared is of the form 3p plus 1 where p is an integer. So n squared is going to be 3k plus 1 all squared. I'm going to write my double brackets. And I can multiply this out to give me 9k squared plus 3k plus 3k, so plus 6k, and then plus 1. Now this is looking quite nice because I can see I've got a multiple of 3 here and I've got a plus 1 here. To do it just fully, I should factorize out a 3 and write 3 bracket 3k squared plus 2k plus 1. And this is an integer. So I've done it basically. I could call this p and then say that's an integer, but I think this is enough. Proof complete. You know what, I probably shouldn't write proof complete quite yet. I've done it for this. I'll just write as required. Case 2 is when we've got 3k plus 2, so then n squared is going to be 3k plus 2 times 3k plus 2. Again, multiply it out to give me 9k squared. And this time I'm going to get a plus 6k and another plus 6k. And then I've got a plus 4. So this one's a little bit trickier to deal with because I wanted a plus 1 at the end. I don't have that. So I need to manufacture that. I need to make sure I do have that. So I can split my 4 into a 3 and then a 1. Yeah, why have I done that? Because now I've got this thing that I want on the end. And we see now that 3 goes into the first 3 terms, so I can take that out. 3 bracket 3k squared plus 4k plus 1 plus 1. Again, this thing here is an integer. As required. I've shown again that it's in the form 3p plus 1. And now I can say that the proof is complete. Just before I move on, I want to give an alternative proof to this. This is really nice that I saw one student give. And it actually doesn't need to break it down into cases. So alternative proof. Okay, so n is not divisible by 3. This implies either n plus 1 is, or n minus 1 is. Okay, one of those must be the case if n is not divisible by 3. Therefore, n plus 1 times n minus 1 will equal 3p for some integer p. Because I know that one of them is a multiple of 3. If I multiply them together, that's definitely going to be a multiple of 3. I can multiply this out. It's going to give me n squared minus 1 equals 3p. So that means that n squared is going to equal 3p plus 1. Now this is more complicated. So when I say more complicated, it's actually more simple, but it's a bit more ingenious, I'd say, this solution than just using these cases. But really nice alternative way of solving this problem that I think is worth looking at.